Okay, now let's look at example 8. The volume of air in fully expanded pair of human lung is 5 times 10 to the power of negative 3 meter cube. So this is the volume. And the pressure of the air in the lungs is 1 times 10 to the power of 5 Pascal. So this is the pressure. And its temperature is 310 K. So this is the temperature. Calculate the number of moles of air in the lungs. So we need to calculate the number of moles. We know our pressure, we know we know the volume, and we know the temperature. So we can use ideal gas equation, which is PV equals to nRT, where P is the pressure and V is the volume, which is 5 times 10 to the power of negative 3. And then N is the number of moles we are going to look for it. R is the molar gas constant, which is 8.31, and the temperature is 310. So rearrange the equation and you press the calculator, you will get 0.194 moles. Okay, we are done for A. Okay, now let's look for B. B, the question asks us to look for the average kinetic energy. Okay, highlight average kinetic energy of an air molecule in the lungs. Average kinetic energy, we have three formulas. The first one is half m mean squared speed. Okay, the second one is 3/2 kT. And the third one is 3/2 R over Avogadro constant times with T. So if you look at the question, the information that we have is the temperature. Okay, and whereas for the K, R and NA is the constant, which we can get from the list of constant and formula. But if we use the equation for number 1, we do not know the mass. We do not know the mass, and we do not know the mean speed squared. Okay, we do not know the mean speed squared. Mean squared of velocity. So we can use formula number 2 to look for the average kinetic energy. So 3/2 times the Boltzmann constant, which is 1.38 times 10 to the power of negative 22, and times with the temperature, which is 310. So the average kinetic energy of an air molecule in the lungs is 6.417 times 10 to the power of negative 21 joule. That's all for example 8.